Hello everyone. In this video we're going to be looking at longest substring without repeating characters, which is LeetCode problem number 3. So this problem states, given a string S, find the length of the longest substring without repeating characters. And this problem is marked as a medium and fairly popular, almost 20,000 likes. So in example 1, we've got this input string, and the output is 3, because ABC is the longest substring. It's actually in there twice, but example 2, BBB, 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 1, because B is the longest substring without repeating characters. And this one is WKE. It says here, PWKE is a substring, but it's not because there's PW, because there's a second W in there, so you can't have repeating characters. All right, so to do this problem, passing in the string and returning back int of the longest substring. So to do this problem, we're going to use the pointer method. So we're going to have I equals 0, which will be the start of the string. And then J is basically going to check each character. So it's going to move to the right one position until, and we're going to record each character until we get to a character that's repeating. And then we're going to remove the first character. So we're going to move I forward. And then, but we're not going to increment J. And so then we'll check that character again, and if we haven't removed the repeating character, then we're going to move I again. And so we'll just keep doing that until we get the longest substring. Now, code that out and we'll debug it, so it'll be much clearer. So we're going to find a hash set. Now, hash set will take an ordered pair, but it doesn't. It takes a pair, but doesn't order it. So when we add stuff to the hash set, it's not like a stack or a queue where we can, use LIFO or FIFO. All right, well, J is less than the length of the string. Okay, if the set does not contain, exclamation mark means not, or the opposite of what the method, or whatever this is trying to do. So set contains S dot character at J. So J starts at 0, so we're going to check the first character. So if it doesn't contain it, then we're just going to add it. We'll add the character, and then we'll increment, increment J. And then we need to find the max. So we'll take the max of max, which we set initially to 0, and then the set size. So the first time through, we're not going to have anything in set, so we'll add whatever's in J, and then the set size will be 1, because max would be currently 0 at that point. Otherwise, if the set contains that character, we need to remove the character at I, the first character, and then we increment I. So we're not looking for, like, let's say J is B. We're not looking for the B character because we need to make sure all the characters are in order, or adjacent to each other. So if we pop one out that's not adjacent, then it wrecks our, ordered fashion or whatever, because they've got to be consecutive order. Okay, so that's that, and then we just return the max after all this is done. So let's debug this. I feel like that will clear some stuff up. So I use the first example. We're just going to go through this. So we'll have everything set to 0. I is 0, J is 0, the max is 0. We'll define a new hash set. So while J is less than S length, so if set contains character, which it doesn't, we're going to add it. So we've got the letter A in the set. And then the math max is going to be 1. Because max is 0 and the set size is 1. All right, so we're going to keep doing this. This is now the B, and we're going to add that 2, and now the set size is going to be 2. And then we'll do the same thing with the C. So you see the set size is 3. So max is now 3. Okay, so we've done A, B, and C. Now you notice the next character is going to be the A. Well, it contains an A. So now we need to remove the first character. So we're going to remove which happens to be the A. So we're going to move the first character, And then we're going to see if we got the right character. So we're going to see if it contains it. It doesn't. So we remove the A, and now we're going to add it and set the size, which is still the 3. Because actually, going back to that, we didn't increase J, so it was actually looking at the A, and it saw that we removed the A, but then we re-added it because we never increased J. So J was still equal to the 4th character, or 0, 1, 2, 3, the 3rd character, which was the A. So it added it back in, basically. All right, so now we see that we're at the B here, and it has a B, so we're going to remove it. But now we're at J4, 0, 1, 2, 3, 4. So we're still at the B, so it adds that back in. Okay, so now we're at 5, which it's going to contain a 5. So now we have to remove the character at I2. We keep going through this. Now we're still at J is still 5. We're going to add that back in. And see if it increases the max, which we haven't done that. Actually, the max is the first 3 characters, so that's never going to get greater than 3. But okay, so now we have a character that is already in the set, so we have to remove it. So if we look at the set now, it's just B and C. We've removed the A, and so now we're at J6, 0, 1, 2, 3, 4, 5. So now we have a C, so we're going to remove that, or remove the character, the next position at I. Okay, so now J6, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. So this is a B. So we're adding a B back in. And now we're removing. The set size is 1. J is 7. We've got a B there, so remove that. Now we're at the last character, which is also a B, the second B, and we're going to add that back in. But it doesn't matter at this point because the set's only up to 2. So basically all we did was we traversed this entire list with the J, and then we come across, so we did A, B, and C, then we come back to the A, so then we have to remove the character at position 0 and go through the list again. We still have the A, so we still retain that value. And then we go through and, we have the A, and it's not already in the list because we just removed it. So it's kind of confusing because we remove something and add something, but we're just trying to make sure that we have unique characters. So like when we get to the second A and it's not unique, we remove the first character and then this becomes unique. So we need to make sure we don't bypass a letter just because it existed before. We're going to remove it until we get to a string where all the characters are unique. So hopefully that makes sense. All right, let's run it through LeetCode. It is successful, and we'll submit it. So we're faster than 48% and use less memory than 98%. So last thing we'll do is go through the space and time complexity. So execution time complexity is O of n. As we increase the input parameter, then we're going to increase, we're building a hash set, so we add numbers to that, add characters to that. The more characters we have, the more potential we have for unique characters. Space complexity is the same thing. We've got a lot more space for a larger hash set that gets created. So both time takes longer time and it takes more memory when you increase the hash set. And that's it. So hopefully that made sense. Let me know if you have questions, and thanks for watching. We'll see you next time.